So when we're asked to combine like terms, remember terms are things that are added. So we have two terms. We have 8n as a term and 3n as a term. And they're alike because they have the same variable, and each variable is to the same power. So n doesn't have an exponent, so it's an understood 1, and that's an understood 1. So if we have 8 of something and someone gives us 3 more of that same thing, then we need to know how many of those do we have. So we add their coefficients together. 8 of them, add 3 more together. Well, 8 plus 3, you have 11 of those. So one important note is we're not changing the exponent. Exponents are for when we are multiplying things together. So they are still n's or n's to the first. We're just adding the coefficients. Here we need to combine what's alike. So one thing I encourage students to do for a while is to put these in order so that the things that are alike are beside each other. So we can arrange these as long as we keep the signs with their corresponding term. So we have a 4b that's positive, we have a 6b that's negative, we have a -6 and a -3. Notice we kept the negative with the 6, the negative with the 6b, and the negative with the 3. So we essentially commuted, we changed their order. So now we put the things that are alike together. Both of those are b's. So 4, we have 4 of them, and then we're taking away 6. Those have opposite signs because the 4 is positive. So when we are adding and subtracting opposite signs, we subtract the digits. 6 minus 4 is 2. Take the sign of the bigger number. Then we have -6 minus 3. Those are both just numbers. Their signs are the same, so if our signs are the same, we add the digits. 6 plus 3 is 9. Take the sign of the bigger number. And that's as far as we can go because the first term has a b, the second term doesn't have a b. So they are not alike. All right, this one is the same type of problem. We just have some decimals involved. So let's rearrange it. We have an x term. So let's write the other x term beside it. And then we have a -6 and a -1.2. So when we're combining the x's, remember we're combining their coefficients. How many x do we have? We have 6.6 here. If we don't have a coefficient there, that's an understood 1. So 6.6 and 1 more would be 7.6. Remember, with the number 1, if you were to put a decimal, it would be right there. So add our columns and we get 7.6. When we combine just our numbers, the signs are the same, so we add 6 plus 1.2. So if we add our columns, we get 2 here, 7 here, so that'd be 7.2. Take the sign of the bigger number. Those terms are not alike, so that's as far as we can go. So what about this one? This one has our variables to the second power. But notice all of these are to the same power. So since they're all to the same power, they're all like terms. They are all r squareds. So if we want to know how many r squareds, we have 4, then we get 10 more, then we take away 5. So when we're adding and subtracting, we just go left to right. So 4 plus 10 is 14, and then 14 minus 5 is 9. So that lets us know how many r squareds we have. Just put the numbers in front of the r squareds together. Now when we get here, they go ahead and give us a hint. We have to use the distributive property. Let's think about why this is. If we think about our order of operation, if there's anything inside the parentheses that we can do that first. Well, inside the parentheses, there are not any like terms. We don't have any exponents. So next, we would multiply or divide before we add and subtract. So we have multiplying here. We saw that if we have a number or a letter in front of our parentheses, that gets distributed to both terms. So we have 5 times D, so 5D. We have 5 times -7, so a positive times a negative, 5 times 7. So we distributed the 5, and we only distribute it to what's in the parentheses. We don't distribute it to the 8 because the 8 is not in parentheses. We just bring our 8 down. And now we combine like terms. We only have one D term, so bring it down. And then for the numbers, it's easy to mess this up. It's easy to see the plus and want to add, but the 35 is negative. So we have opposite signs. One is negative, one's positive. So opposite signs, we subtract. If we subtract that, we have to borrow 1, which makes this 15. 15 minus 8 is 7. Bring down your 2. So we get 27. Take the sign of the bigger number. Those are not alike, so we stop there. Have the same type of thing here. Inside either parentheses, there are not any like terms, so there are no parentheses to do. There are no exponents to do, so we need to multiply. So we're going to distribute the 4 to the first parenthesis. So we have 4 times x, which is 4x. And then we have 4 times 2, which is 8. And then for the next one, we have a minus in front of that parenthesis. And there are several ways to look at dealing with a minus in front of a parenthesis. We could think about that as an understood 1, and then we are distributing that 1 to both numbers. So -1 times 2x, so negative times positive is negative. 1 times 2x is 2x. And then -1 times -8. -1 times -8. Negative times negative is positive. 1 times 8 is 8. Some people think about that as a negative means the opposite. If I have a -3, that means the opposite of 3. If I put a negative in front of that, that means the opposite of this. So the opposite of -3 would be +3. So if we have a 2x minus 8, if we want the opposite of that, because there's a negative in front, the -2x would become or the positive 2x would become a negative. The positive 8 would, or -8 would become a +8. So we would change both of those signs. Either way, we end up with -2x plus 8. Then we combine what's alike. So we put the 4x and the -2x together, the 8 and the other 8 together. So 4 minus 2 would be 2x. 8 plus 8 would be 16. And those are not like terms, so that's our answer. Has the same type of thing here. Nothing in parentheses can be done, no exponents. So we multiply 3 times 2x. Well, 3 times 2 is 6 times x. And 3 times -1. Positive times negative is negative. And 3. And then we distribute the -2. -2 times x. -2x. -2 times -9. So negative times negative is positive. 2 times 9. And then we combine things that are alike. So we have a 6x, and eventually we take away 2x. We have a minus 3, and then we get 18. So 6 minus 2 is 4. Those have opposite signs, so we subtract them. We get 15, and the larger number is positive. This one is easy to miss if we aren't careful, because it's natural to see 7 plus 6 and want to put those together as 13. But we have to use our order of operation. Inside parentheses, there's nothing to do, and there's not an exponent, so we have to multiply before we add. So we can't do the adding over there first. We're not allowed to do that part first, because we have to multiply. Oops. I'll get this to close. We have to do the multiplying before we do the adding. There we go. Oops. So before we can add, we have to do this multiplying. So we just bring down the 7, and then we do 6 times 2c. So 6 times 2 is 12 times c. So take that disappearing marker off. So 6 times 2c, so 6 times 2 is 12 times c, and then 6 times negative 1. Positive times negative is negative, 6 times 1. So if we put the things that are alike together, we have a c term, 12c, and we have some things that are just numbers. So 7 minus 6 is 1, and it's positive because the bigger number is positive.